Hello, today we are learning about a key topic in momentum, which is called elastic collisions. To understand what an elastic collision is, let's first understand the idea of a collision. So a collision is when two or more objects collide into each other. From what happens after that makes a collision elastic or inelastic. In any collision, the conservation of momentum is conserved. However, only in elastic collisions where the conservation of kinetic energy is conserved. So let's say there's a ball one traveling at a certain velocity, and it hits a ball two at rest. When they collide, ball one will be at rest, and ball two will travel at the same velocity as ball one hits ball two. So in the system, the energy before the two balls collide is equal to the energy after the two balls collide. Therefore, the conservation of kinetic energy is conserved. So in this collision that we have here, we call this a perfectly elastic collision, which means that all the energy from before collision is the same as all the energy after the collision, which in real life isn't always true. This is only true when we look at the atomic level of particles. So like when two molecules collide with each other, it will be a perfectly elastic collisions. But in real life, a lot of energy is lost due to sound energy and thermal energy. So there are three cases we have to consider when we deal with elastic collisions. The first case is when mass 1 is equal to mass 2. The second case is when mass 1 is much greater than mass 2. And finally, the last case is when mass 1 is much less than mass 2. So the first case is when mass 1 is equal to mass 2. So when mass 1 comes at a velocity and hits mass 2, which is at rest, then mass 1 becomes at rest and mass 2 will be at velocity. Therefore, this velocity is equal to this velocity due to the conservation of kinetic energy. So the second case is when mass 1 is much greater than mass 2. So when mass 1 comes in at velocity and hits mass 2, which is at rest, mass 1 will still be continuing on at a slower velocity than this, and then mass 2 will be now moving in the same direction as mass 1. And remember, in this case, the energy before the collision is still the same as after the collision. So the final case is when mass 1 is much smaller than mass 2. So when mass 1 comes at a certain velocity and hits mass 2, which is at rest, mass 2 will still be at rest because the difference in mass is really great. So then mass 1 will come back in the opposite direction, but at the same magnitude as it came in. So one application that we use in elastic collisions is when we play billiards or pool. Since all the balls are in rest except for one, when it comes into contact, there is almost no loss of energy due to the materials of it. So then we can say that this is almost a perfectly elastic collision.